Okay, you guys, now we're starting a new chapter. The chapter is called Chapter 8. You might say, wait a minute, we just finished Chapter 10. And I say, yeah, remember we skipped Chapter 8 and I told you we were coming back to it. Well, guess what? We are coming back to it now. So that's the thing. We're jumping back to Chapter 8. We're going to do our first section. We're going to skip the first two sections of Chapter 8. And we're going to start with Section 3 called Long Division of Polynomials. Long division of polynomials. Now, that, you might be thinking to yourself, long division of polynomials, that does not sound very fun. And the only reason is because it is not very fun. This is one of my less desirable things we've got to learn. How many people love long division? Nobody, including me, including you. But you know what else I don't love? Vegetables. But sometimes my mom makes me eat them. So the same thing. It's good for you to learn how to do long division of polynomials. And after you make your way through this and learn this thing, which you're probably not going to love learning it, but it gets better tomorrow, or the next section gets better. So just bear with me. Bear with me through this, okay? Here we go. Long division of polynomials. We're going to start off back in like 4th grade or whatever. So most of you guys have seen this already. Here's what we got. 2031 divided by 37, okay? It's like, okay, boys and girls, we're going to learn how to do long division today. You might have heard about this from your older brothers and sisters or something like that. I don't know. But here's the deal. This is how it works. The bottom number goes on the outside. The top number goes on the inside. And this is how you set up long division with this little backwards L kind of thing here. Why? It just works. Just accept it, okay? So this is how it works, okay? Now, this is how you do long division, okay? Bottom number outside, top number inside. Here's what you do. You say, how many 37s are there in, you start with these just digit by digit. How many 37s are there in 2? You say, well, none, because 37 is bigger than 2. And I say, right. So then you look at this as a 2-digit number. You say, okay, 20. How many 37s are there in 20? And you say, still none, because 20 is still smaller than 37. And I say, that's correct. So you say, well, and how many 37s are in 203? Well, there's going to be some, because 203 is bigger now. Now, how many? Gee, I'm not sure. I'm going to show you a little trick. Look, 37. Is that closer to 30 or is that closer to 40? If you're rounding it off, it's closer to 40. So if I cover up this digit, see, some people will tell you, just cover up this digit and use 3. But I say, cover up this digit. But if this is big enough to, if this makes this closer to 40 than 30, I would consider this to be a 4. There should be about the same number of 4s as there are in 20 as there are 37s in 203. About. Now that could get us off by 1. There could be 1 more or 1 less, but it gets us to the right ballpark at least. There should be about, how many 4s are there in 20? There's about 5. So there should be about 5 37s in 203. Now, we'll find out. Is there 5? Is there exactly 5? Could there be 4? Could there be 6? Let's find out. So what do? You say, okay, I guess 4, and I put it above the last digit. So I'm calling this 203. If it was 2, if I was just using 2, I'd put it here, but I'm using 203, so I put my 5 right there above the last digit, okay? Then I multiply. This times this is 5. 5 times 7 is 35. Carry the 3. 5 times 3 is 15, 16, 17, 18. And then the next step, don't ask me why, this is what you do, subtract. 13 take away 5 is 8. Uh-oh, wait, I can't borrow and make that 13 because there's nothing here. So I have to borrow from this and make it a 1. I have to make this a 10. Notice, I borrowed 1 from here, made it 10 in this thing, but now I have to borrow one of those 10s to make this 13. Now this is like 2nd grade stuff. Hopefully you're following this. 9 take away 8 is 1, and this is nothing. Now, 18 is left over. It's if this number is smaller than this number, then yay, we picked the right number. 5 was the right number. If this number was bigger than 37, that means, oh, there was one more 37. I'd have to pump it up by 1. I'd have to pump it to 6, right? If this number's bigger than this number, then I picked a number too big. But since this number is smaller than this number, that was the right thing. Now, the next step, don't ask me why, is to bring down the next digit and make this 181. And again, how many 4s, because 37 is closer to 40 than 30, right? How many 4s are in 18? Well, 4 times 4 is 16, so it'll probably be 4. 4 times 7 is 28, carry the 2. 4 times 3 is 12, and 2 more is 14. So there it is. Now subtract, okay, subtract. See what happens. 11 take away 8, oh, we got to borrow, make that a 7. 11 take away 8 is 3. 7 take away 4 is 3. 33, it's still smaller than 37, so that's right. So 33 is left over. Now, what do? Well, if you're in 4th grade, at least when I was in 4th grade, that's a long time ago, but you could go remainder 33, right? But that's just for the that's for the baby 4th graders. You know what we are? We're big 5th graders. So we don't say remainder 33 anymore. This is what we do. We do 54 and this number over this number. 54 and 33 37ths. That's what us big 5th graders do. Get it? Okay. That is called long division, and that's what you should have learned in elementary school. If you didn't, well then thank God you learned it now. Okay, now, I'm hoping that nobody just learned anything right there. Hopefully I just reminded you of something you already knew. If you didn't know, at least you learned it now, but you should have already known that. Now, why did I go through all of something that you should have learned in 4th grade? Because now we're big boys and girls. We're in high school now, and we're gonna actually do the same thing with actually polynomials. And it's gonna be the same idea. Okay, here's how it works. You take this polynomial divided by this polynomial. Notice the bottom one goes on the outside, the top one goes on the inside, and you do it exactly the same way. That's why I wanted to do one of these, so you'd see exactly the process. Here's what you do. You say, okay, what does it take to turn first guy, in this case 5x, into this first guy, 5x to the third? What do I have to times 5x by to turn it into 5x to the third? Well, look, I've already got the 5, don't need a number, right? And I need 5x. I've already got one of the x's, but I need an x squared. It's gonna take 5x times x squared to get x to the third. So that's what I'm gonna have to put up here is x squared. Now, how do I know where to put it? I count over, 1, 2. There's 2 here, so I'm gonna slide 2 spots over, and I'm gonna put it right above, notice x squared, I'm gonna put right above the squared term right there. So I'm just gonna put x squared, okay? Notice, how did I get x squared? What does it take to turn 5x into 5x to the third? It's gonna take x squared, I put it above the x squared right here, okay? Now multiply. X squared times 5x is 5x to the third. Yay! Not yay. It better be 5x. If it's anything other than 5x to the third, you screwed up, okay? So it needs to be the same. That was our whole reason for picking x squared, right? And then finally, minus 3 times x squared would be minus 3x squared. See how the x squareds line up and the x thirds line up? Now, what did we do when we were back in 4th grade at this point? We subtracted. So that's what we're gonna do here. But you know what I'd call it? Watch. If I want to subtract this thing, subtracting is the same thing as adding the opposite. So you know what I'm going to do? I'm going to make this a plus, and then I'm going to just distribute a negative. So this used to be positive, it's now negative. This used to be negative, it's now positive. See how that's the same thing as subtracting. I'm just doing this guy take away this guy. So look, this and this is 0, which it always will be 0. It should be 0. If it's not 0, something's wrong for the first terms right here, okay? What's 7x squared plus 3x squared? That is 10x squared. Then what do you do the next thing? You bring down this. So you bring down the minus 26x, okay? Now, what happens there? Well, you say, what does it take to turn this guy into this guy, okay? To turn 5 into 10 is going to take 2. To turn x into x squared is going to take x. So it's going to be 2x. So I'm going to write, positive 2x. So I'm going to hit plus 2x. See, I'll put it right above the x right there, okay? 2x times 5x is 10x squared, just like I was expecting, yay, okay? 2x times negative 3 is minus 6x. Now, my next step is to subtract that, but remember, I like to call it adding opposites. So make that a plus. That's going to change these signs, negative, plus. This and this is 0. Minus 26 plus 6 is just minus 20x. Bring down the last thing, plus 12. What does it take to turn first guy, 5x, into this guy, negative 20x? It's going to take negative 4. So I get negative 4. Negative 4 times 5x is negative 20x. Negative 4 times negative 3 is plus 12. Subtract. But remember, subtracting is the same thing as adding the opposite. So I make that a plus. That means change these signs. This is a plus, this is a minus. Look, nothing, nothing, nothing. Nothing left over. No remainder. What that means is this thing divides by this thing evenly, and this is the answer. It also means if you were to take this binomial and times it by this trinomial and multiply it all out, you would end up with this answer. They divide nicely without a remainder. But there's the answer. Okay? Same idea. Exactly the same idea as long division you learned in elementary school. Okay? It's just a little more involved with this polynomial stuff. Okay? Let's do another one. Now, the last problem I didn't have special conditions like this one's going to have. I'm going to point out something right now that's very, very important that you need to pay attention to. And that is when I write these, okay, this guy divided by this guy. First of all, I don't want negative 7 plus x. I like to put it in decreasing powers of the variable. I would call this x minus 7, and that's what I'm going to put it when I do it out here. But even more importantly than that is this. Every single power of the variable has to be accounted for when you're doing this. If there's any missing powers, you have to put zeros in for them, just like over here. See this number 2031 when I divided by 37? See that 0 there? Now, what is the 0? Is there a digit in that thing? No, it's more like a placeholder, right? The reason the 0 is there is because if it's not there, this 2 would slide into the hundreds place, and it would be 2 in the hundreds place, but we want 2 to be in the thousands place, so I need to put a 0 as a placeholder in that hundreds place so that everything works out good, because every place, the ones, tens, hundreds, thousands, has to be accounted for. Same thing with polynomials. X to the third, x squared. Notice there's a missing x term. So you have to account for it. You have to put a 0x. If there's other missing terms, you have to account for them. You have to account for every single term. If there's any terms missing, you have to account for them with zeros, which is why I put it like this. Look, 4x to the third minus 25x squared plus ox. It's an ox, okay? And then minus 50, don't forget the ox, okay? In this case, if you do, it's gonna mess you up, okay? So you have to account for every missing term, and account for the missing ones. Okay, so now, once you make sure and account for the missing 0 terms, then this problem will be just like this last problem. Okay, so what does it take to turn x into 4x to the third? Well, it's going to take 4x squared. So notice I'm going to put it right above this x squared, 4x squared. The next step is to multiply. 4x squared times x is 4x to the third, just like I expected it to be. This times this is minus 28x squared, okay? Next step is to subtract, okay? So I'm going to subtract, but tricky me, I'm not going to subtract. I'm going to add the opposite, which makes this negative, makes this plus. Same thing as subtracting. This and this is 0, just like I planned. Negative 25x squared plus 28x squared nets out to be 3x squared. And then what do? Drop the ox. The ox drops. Okay. Now what happens next? What does it take to turn x into 3x squared? It's going to take 3x. Okay. Notice I put it above the x right there. 3x times x is 3x squared. 3x times that is minus 21x. See, if I didn't have that ox right there, where would I line up this 21x? There would be no x term to line it up with. That's why you want to count for every term. Okay? Now I want to subtract. So tricky me, I'm going to call that adding the opposite. So I'll make this a plus, but then I have to change the signs there. This adds up to 0. This adds up to 21x, and then bring down the last thing, minus 150. Okay. Now, what does it take to turn x into 21x? Well, obviously 21, right? So I add 21 plus 21. 21 times x is 21x. 21 times 7 is, I don't know, let's see, negative, okay, watch. 2 times 7 is 14, 1 times 7 is 7. 14, 7 is known as 147. Oh yeah. Subtract, add the opposite, so plus, negative, plus. This is nothing. Negative 150 plus 147 is negative 3. So negative 3 is my leftover, right? My remainder. So the answer is going to be this guy. It's always this guy plus whatever's left over, negative 3 over this guy. You could call it negative 7 plus x. I'll just call it x minus 7. Doesn't matter if you call it x minus 7 or negative 7 plus x. Or you could even put this as, instead of plus negative 3 over this, you could just put minus 3 over this. It doesn't matter if you put the minus up here or the minus out front, either way. But this would be the answer. So this one does have a remainder. This is how you deal with it if it has a remainder. You always put this guy over this guy. Okay? Now, that's how to do those. It is, like I said, a lot of fun? No. Super difficult? No. Rather long, tedious, and boring? Yes. That's the problem. Okay, but that's what, sometimes you get paid the big bucks. That's what you got to do. Okay, so here we go. Look at this last guy. Not last guy. We got one more after this, but second to the last guy. 2x to the fourth minus 3x to the third plus 4. There's a missing square term and a missing x term. So look what I did here. I went ahead and put the bottom guy right here. Look, fourth power, third power, missing x term, missing x squared term, missing x term. I had to account for all of those. Make sure you account for any missing terms with zeros. However many missing terms there are, they have to be accounted for with zeros. Okay, now we're ready to roll. Here it goes. What does it take to turn x squared into 2x to the fourth? Well, it's going to take a 2 and an x squared. So notice I put it right above my x squared here, which thank God I put the zeros there, or I wouldn't have an x squared term to put it above, right? So good thing I did that. Now, next step, this times this, this, and this, and I put them right here. So 2x squared times x squared is 2x to the fourth, just like I expected it to be, yay. This times this is minus 6x to the third. okay? This times this is plus 10x squared. That's what I get when I do this guy times all this. Now, I need to subtract, but I'm gonna call that adding the opposite, right? So I'm gonna make this a plus. Now notice that changes all these signs. This used to be positive, it's now negative. Used to be negative, now positive. Used to be positive, now it's negative. Change them all. Add these together. This should always cancel. This should always be 0, right? Negative 3x to the third plus 6x to the third is 3x to the third. 0x squared minus 10x squared is minus 10x squared. Uh-oh. Drop the ox. Like that. There's the, ooh, it's a blue ox, like Babe the Blue Ox. Okay. And then, and then, let's see what happens next. What does it take to turn x squared into 3x to the third? It's going to take 3x, right? So put it right above this, 3x. 3x times this is 3x to the third, yay, just like I wanted. This times this is minus 9x squared. This times this is plus 15x. The next step is to subtract, which I'm going to treat as adding the opposite, so negative plus negative. This is 0. Negative 10 plus 9 is negative 1x squared, or just negative x squared. 0x minus 15x is minus 15x. Bring down the 4. Now, what does it take to turn x squared into negative x squared? It's going to take negative 1, right? This times this is negative x squared. This and this is plus 3x. This and this is minus 5. And I'm going to subtract, but tricky me, I'm not going to subtract. I'm going to add the opposite. 0 minus 18x plus 9. That is the remainder. That is what's left over. So remember, I'm going to be going this guy plus this over that. And if you do it correctly, the top, or the numerator, should always be at least 1 degree lower than the denominator. Look, this is x squared, this is x. That should always happen. This should be at least 1 degree lower than the denominator, if there is a remainder. Boom, there you go. That is that problem. Now, one last problem, okay? Like I said, I know this isn't the funnest thing in the world to do, but you need to know how to do it because sometimes it's going to be necessary. I'm going to show you this thing we're going to learn next time is a shorter way to do some of this, but you can't, it doesn't work on all the